Hello everyone, my name is Tim,
My name is Mohammed.
and we're going to talk about, what are we talking about? Roots?
Yeah,
Root means square. So, I got some roots. So, roots are green. I mean, well, not the roots are green, the roots are brown.
Roots. I'm not sure that's what we're talking about here, though.
But they're roots.
Yeah, I don't see any squares in there, though.
You're a spoiler.
Oh,
Alright, so, what do you suppose root means square is?
what do mean square? That's got to be a measure of power, electricity. It's got to be something.
Yeah, 'cause it's on meters, right?
Yeah, it's on meters, so you can
Yeah.
measure it. Yeah.
I wonder where it came from.
I don't know. Maybe
So, maybe we need a little history lesson.
I have to go back in history. Huh?
Back in time. Time travel! Yes! Woo! Okay, so we're gonna travel back in time to when we didn't have lights. People used candles,
Oh,
and this guy invented the light bulb. So,
okay.
this guy that invented the light bulb, what was his name?
Oh, that looks like Thomas Edison. Right
And he's
there.
holding the light bulb.
Yeah, ooh.
Hey.
Picture of the light bulb right there.
Wow. Is that light bulb you stick in your mouth and it glows?
I don't think so.
There was a movie about that somewhere.
Yeah,
right?
somewhere.
Okay, then we're not the same guy though, right?
Not the same guy.
Yeah.
Yeah.
Okay, so this guy invented basically the light bulb, and he was using direct current to light all this stuff up.
Yeah. Yeah.
Yeah. The nice thing about DC is about every so often you'd actually have to build this huge power plant, and they couldn't be very far apart from each other.
Right. So.
A lot of money in that,
Yeah.
right?
Lots of money.
So he was investing heavily. He was going down the road. He was making some money, feeling good, on top of the world. Had his own
Yeah.
company. Man, people were coming to him. He was in the newspapers.
He had all
He
the
lights
power.
it off. Yeah. He
all
was,
the power.
He was sitting good, and he
Yeah.
wanted to keep that, right?
Yeah.
Well, just like you're a spoiler, he had a spoiler too. Well, come find out, this guy named Tesla. Looks pretty serious there, huh?
Yeah.
Yeah, looks pretty serious. You know about Tesla?
Kind of looks like a spoiler. Yeah.
Yeah. Well, he came in, he had an idea.
Yeah.
Well, he had an idea that maybe DC wasn't such a good idea.
Right.
I mean, it has its applications,
Yeah.
but maybe if I come up with something a little bit different, and he called it AC, alternating current, that now I could get over those little problems I have with DC and having to put a whole bunch of power stations close together to keep that power up,
Yeah.
having this huge power loss over distance.
Right.
With AC now, I can use transformers
Yeah.
relatively easily. I can ship high voltage over long distances with low current and have much lower loss.
Right.
Sounds pretty
Yeah.
attractive.
Yeah.
Don't have to have as much infrastructure.
Yeah.
Sounds like an easy win, doesn't it?
It does.
Well,
Power Edison, I'd be worried.
well, I would be worried too,
Yeah.
especially without making all that money.
Yeah.
But what do you suppose he did?
I'd have tried to, shame him,
Scare
to
people?
Scare people away from his ideas.
Yeah, because scaring's a good tactic, right?
Yeah,
Scaring
fear.
people usually works.
Fear
Okay?
is a powerful, feeling.
Yeah. So let's take a look. Whoa. Holy cow.
Oh.
I've seen that before.
Yeah, the electric chair.
Yeah, not something I'd want to have in my house.
No, that's, it's a one-time thing, for sure.
Yeah, it's a very shocking
Yeah,
experience.
very shocking experience.
Definitely associated with death.
Yeah.
Okay?
Yeah.
Dead people. Now, do I really, want to associate something I want with dead people?
Right, yeah.
So, good ploy, right?
Yeah, so we're knocking down this AC stuff right here.
But I think I can do better.
Okay.
Now, I'm fine. What was his name again?
Edison?
Edison. I really want to shock people. Okay?
Oh, okay.
So I'm gonna start killing stuff.
All right, we're gonna show 'em something
I'm
crazy,
gonna,
huh?
I'm gonna do some killing.
Yeah, okay.
So, whoa. I got some elephants.
That's an elephant.
That's
right
a
there.
big elephant.
Yeah.
Okay? And I'm gonna kill it with
Wow.
electricity.
Okay. Wow, you took out that whole elephant right there.
Not just part, we
Not
took out
just
the whole
part,
thing.
The whole thing. It's
Wow.
done.
It's pretty scary.
Yeah.
I don't think I
Pretty
want to
good.
mess with AC.
Yeah.
That's pretty deadly, right?
Yeah.
Yeah, wow. Yeah, that would scare me off.
Right. Okay.
However, money usually wins, right?
That's true. Money's
Yeah.
almost overall.
So somewhere along the line, people figured out that this AC thing was a pretty good idea.
Yeah.
Yeah, I can
Yeah.
transform it pretty easily. I can ship it over long distances pretty easily. A lot better than the DC, a lot less expensive.
Eventually Tesla won.
Yeah. I mean, he was dead though.
Yeah.
Didn't get much of the profits.
It's hollow win.
Yeah. Well, let's talk a little bit about what AC and DC are.
Okay.
Well, if I look at DC over here, pretty flat line.
Yeah.
Not real complex, not a lot going on here.
Not too fancy.
So I could have some really easy meters to measure that.
Yeah.
And I get what I get is what I get.
That's pretty much it. Yeah.
However, I look at this.
Oh, got some sine waves.
That it's sinusoidal waveform going up and down, up and down.
Yeah.
Wheels on the bus go round and
Yeah,
round,
yeah.
round. Well, anyway.
Just
Okay.
about.
So I look at this and I go, wow. There's a high voltage, it goes to zero, goes to a low voltage, it goes back and forth. So it's not constant.
No.
That DC thing was pretty constant.
Yeah. it's,
Yeah.
You know, that's
Very
it.
steady, very reliable.
Yeah,
Okay?
Yeah. Can't go wrong with DC, but the AC stuff, I don't know, man.
Well, we have to figure out, because we're battling, Edison, we have to figure out,
Yeah.
how do I figure out what that value is compared to DC?
Yeah, we're gonna have to do some math.
Yeah, we're gonna have to do some math. So I look at this form, this right here, and there's my sinusoidal waveform, means it's a perfect waveform, up and down.
Right.
Kind of reminds me of a roller coaster,
Yeah.
okay? So the top value to the bottom value is called our peak value.
Right.
However, they have this value here, which is called the RMS value, the difference between here and here, or the average value,
Yeah.
okay? So in that 360 degrees of the cycle going up and down,
Right.
I come up with this thing that's the average usable voltage, okay?
Okay.
That average usable voltage, in this case, is 240 volts, and that's comparable to DC at 240 volts.
Right. Okay.
So this is a comparison. I mean, makes sense right now, right?
It's starting to make sense.
So all I have to do is take my sinusoidal waveform. Look, if I take this one right here,
Yeah.
perfect sinusoidal waveform,
Yeah.
multiply it by 0.707, and I can get my root mean squared,
Right.
or my average. We don't live in a paper wheel, do we?
No, sadly we don't.
Okay, so let's move over here. Your eyelids are getting heavy. You're falling deep into a trance of AC. Well, let's take a look at AC. If I look at my scope over here, does that look anything like a sinusoidal waveform?
No, that kind of looks like a. I don't know, it's kind of crazy over there. I don't know about that.
Yeah, this is my output from a drive. So we have a nice drive set up here, and it's putting out what looks pretty much like crap.
Yeah.
Okay? If I come over here with a meter and I turn the meter on, it's going to measure the voltage because it's an RMS meter. Do you hear that beeping?
Yeah, that beep.
It's going to drive me crazy.
Yeah. And
Okay.
it just keeps on going on because it's trying to keep up.
Yeah, it's trying to keep changing its ranges because
Yeah.
it can't figure out what's going on.
Right.
So, now I've got this complex waveform I've got to try and figure out.
Right. Okay.
Well, I could use the math.
Okay. Let's get into the math.
Let's give the math a chance.
Oh. Well.
Oh my gosh.
Oh.
Am I going to do this all the time?
Nah,
I
yeah,
probably
that's
want something to help me with that,
a,
right?
yeah, we can probably find something to help us out with that. That's
And
a little too much.
yeah, we call that,
And that. We
Yeah.
find enough for that.
and it's built into
Yeah.
my meters.
Yeah.
And my built into my RMS meter has all those formulas. It sees all that crap that's coming in
Yeah.
and figures it all out for me. Nothing
No.
better than that, right?
No math.
Are all meters created equal?
No.
So some
Sadly.
meters are better than others, some sample faster.
Yeah.
So we need to get the right meter for the right job.
Right.
That's RMS. Thank you.
Cool. No problem.
Well, this is Tim,
My name's Muhammad.
and we're out.